Welcome to lecture on hydrology and hydrological cycle. Myself Dr. S.Rangasamy, Professor, Department of Civil Engineering, K.S.Rangasamy College of Technology. So hydrology and hydrological cycle, which is an important unit in water resources engineering. Hydrology plays a vital role in civil engineering, especially in the planning and design of water related structures. Introduction to hydrology. Hydrology is the science that deals with the occurrence, distribution, movement and properties of water on the earth and in the atmosphere. It is an important branch of civil engineering because water affects the design and planning of dams, reservoirs, canals, bridges, drainage system, flood control and water supply project. Therefore, a civil engineer must have good knowledge of hydrology. The scope of hydrology is very wide. It includes the study of rainfall, runoff, evaporation, infiltration and groundwater hydrology. Also helps in flood estimation and control of groundwater analysis and water resources planning and management. Hence, hydrology is essential for sustainable development of water resources. Hydrologic cycle, also called as water cycle, describes the continuous circulation of water between the atmosphere, land and oceans. It is a natural process and has no beginning or end. The cycle ensures the availability of water in different forms of the earth. The main components of hydrological cycle is evaporation, conversion of water into vapor due to solar heat; transpiration, loss of water vapor from plants; condensation, formation of clouds; precipitation, rain, snow, hail, etc. Infiltration, entry of water into soil. The soil is penetrated into soil is called as infiltration. Runoff, flow of water over the land surface. Groundwater flow, movement of flow below the surface. The next one is climate and water availability. Climate refers to the long-term average weather condition of a region, such as rainfall, temperature, humidity and wind. Climate has a strong influence on water availability. High rainfall results in more surface and groundwater, while high temperature increases evaporation losses. Dry climate often face scarcity of water resources, and climate also controls river flow patterns, reservoir storage and agricultural water demand. The climate controls river flow patterns, reservoir storage and agricultural demand. Water balance equation. The water balance equation represents the relationship between input, output and a storage of water in a system. It is based on the principle of conservation of mass. The equation is very useful in hydrological analysis of water resources. The water balance equation represents the conservation of mass of water in a hydrologic system. P equal to R plus E plus delta S, where P equal to precipitation, R equal to runoff, E equal to evaporation and evapotranspiration, and delta S, change in storage, soil moisture, groundwater reservoirs. The equation is used in watershed analysis, reservoir operation, water resources planning. Forms of precipitation. Precipitation occurs in different forms such as rain, snow, hail, sleet, drizzle. These forms depend on temperature and atmospheric conditions. Next one is types of precipitation. Convective precipitation caused by heating of air, usually short in duration and high in intensity. Orographic precipitation, which occurs when most moist air rises over mountains, causing heavy rainfall on the window side. Cyclonic precipitation caused by low pressure system and covering a large area rainfall. Measurement of rainfall. Rainfall is measured using instruments called rain gauges. Rain gauges are mainly classified into non-recording and recording rain gauges. The Siemens rain gauge is a common non-recording gauge type that measure total rainfall. Recording rain gauges such as dipping bucket and weighing bucket types record both intensity and duration of rainfall. Rainfall is expressed in millimeters, mm. Then estimation of missing rainfall data. In some cases, rainfall data may be missing due to instrument failure or other reasons. In such situations, missing rainfall data is essential using standard hydrological methods to ensure accurate analysis. The following method used to analyze the missing rainfall data. First one is arithmetic mean method, normally used when rainfall at surrounding station is uniform, and second one normal ratio method, it is used when normal rainfall varies more than 10%, and last one inverse distance method, weights are based on distance between stations and more accurate for uneven terrain. Evaporation. Evaporation is the process by which water changes from liquid to vapor from free water surfaces like lakes and reservoirs. The factors affecting evaporation include temperature, wind speed, relative humidity, solar radiation and atmospheric pressure. Evaporation plays an important role in water balance studies. Then measurement of evaporation. Evaporation is measured using different methods such as pan evaporimeter, especially that class A pan, which is the most commonly used methods. Atmometers, energy budget method and mass transfer method. These methods help in estimating evaporation losses accurately. Evapotranspiration. Evapotranspiration is the combined loss of water due to evaporation from soil and transpiration from plants. It is very important in irrigation planning, crop water requirement calculation and water balance studies. The method of analysis is using following method. First one is Penman-Montague method is the most accurate method for estimating reference of evapotranspiration. It gives accurate result by considering climatic change and crop related factors, where Rn equal to net radiation, G equal to soil heat flux, T equal to mean air temperature, U2 wind speed, Es minus Ea vapor pressure deficit, delta slope of vapor pressure curve and gamma psychrometric constant. The next topic is infiltration. Infiltration is the process by which water enters the soil surface. The factors affecting infiltration includes soil type, initial moisture content, vegetation, rainfall intensity, surface flow and soil compaction. Infiltration is important for groundwater recharge. recharge. The soil type, the different soil types also affecting the infiltration. For example, clay soil mostly affect for infiltration, and initial moisture content in the soil is analyzed, and rainfall intensity. So per day or per week or per month we are going to collect the data for rainfall, and you will calculate rainfall intensity, and soil compaction is also one of the factors affecting infiltration. Horton equation. Horton equation is used to represent the variation of infiltration capacity with time. It is commonly used in hydrologic studies related to runoff estimation. Here Cartan formula is the empirical equation to represent infiltration capacity, F equal to Fc plus Fo minus Fc into e power minus Kt, where small f equal to infiltration capacity at time t, Fo initial infiltration capacity Fc, final infiltration capacity K, dk constant. It shows that infiltration capacity decreases exponentially with time. Thank you for watching. Thank you.